Hello, welcome to my Lab 2 Motion of a Falling Object.
Hi, so today we are going to use Tracker to track the motion of my model Crumble paper ball to see how acceleration affects it. Over here is a positive x direction and this is a negative x, but since we're tracking how acceleration and gravity affects the ball, we're going to focus on the positive y-axis and then the negative y-axis. So here's my clip control. I changed it to make sure that it is 30 frames per second. My starting frame is 210 and my ending frame is 222. And then after that, I took a track control, mass A, and then I tracked it. And this is what it would look like. I also tilt the coordinate system to compensate for the tilt of the angle, the tilt of the camera. So now we are going to use Python to code for a computer model to represent our experimental model. The initial position is at 0 and initial velocity is at 0 as well. Delta t is kept at small to keep the results accurate. The gravity is 9.8 and j hat vectors to represent the up direction for the y-axis. Right now we are disregarding the drag force to compare it later on. In the actual calculation, I put the duration to be less than 0.233 because that's how long my model ran. This is the weight force on the system by this equation, and F net will equal to weight. And then we just go into a continuous loop. After I ran this program, I actually graphed it with my model to compare how it would look. And it's actually, this is my model and this is the experiment. So the computer predicted it way off. So now we're going to see how the drag force will affect it. So now we are going to go back into Python to add the drag force. So here, I guess in check B, I define B to be 0.024123. And after that, I went back into the calculation loop to add the drag force. So here, FD, the drag force, is equal to negative B, which is the proportional constant, times the magnitude of the ball times ball velocity again, which means that it is proportional to the square of the speed. So after running this in Python, I grabbed the CSV file and I compared it with the original graph without a drag. As you can see here, this was the original one without a drag, and then that's the one with a drag, and that's my model position. I'm not sure what that is, but I'm only looking at this curve right here. As you can see, it's pretty accurate compared to this one that's way off. So now for the what if question. What if I throw the ball down faster and harder so the ball won't start at a velocity of 0? So we're going to test that out. Oh, and then how would that affect the terminal velocity? So first I'm going to run it when the velocity is 0. You can see the drag force right there. Now, what would happen if I change the ball velocity to start at a velocity of 1? Notice I put it in the y direction. see how small and long it took for the drag force to actually come out? So because terminal velocity is achieved when the drag force balances out the force of gravity going down. So if the acceleration is greater because I'm throwing it down harder, it will take longer for the ball to reach its terminal velocity.
Thank you for watching.